All right. So we are actually skipping section 4.5. So this is section 4.6. 4.6, which is on all right. So we're going to start talking today about rational equations and partial fractions. So rational means fractions. So basically we're working with equations that are fractions in a nutshell. Okay.
What's the end of the quarter?
Friday.
This Friday?
Yes.
Oh, thank God.
Okay. And the first quarter is this Friday. Yes.
This Friday?
This upcoming Friday. Yes.
We still don't have our quiz scores.
Wasn't midterms just like last week? I'm fine with it. I'm fine with it. That's fine.
Okay. All right. Again, we are recording, so keep the talking to an absolute minimum, please. For the sake of those of you that are working on that, we'll have to come back and watch. All right. So again, the key point here, when we're talking about rational equations, we're talking about equations that have a fraction of some kind in them, because that's what rational means. Okay? So the first example we're going to look at, I'm going to read it to you, and then I'll give you the equation, and we'll figure it out from there. If a scuba diver goes to a depth greater than 33 feet, the function T of D equals 1700 divided by D minus 33 gives the maximum time a diver can remain down and still surface at a steady rate with no decompression stops. Okay? So in this function, T of D represents the dive time and D represents the depth in feet. If a diver is planning a 45-minute dive, what is the maximum depth the diver can go without decompression stops on the way back up? So, what you're talking about here, if you've seen or ever heard of the bends that divers can get if you go too deep and then come up too fast, you can get what's called the bends. And that's basically your body is surrounded by too much water pressure, and if you come up too fast, the oxygen level in your blood is not balanced yet, so you have to stop and decompress your body at certain points. You come up too fast, the oxygen bubbles start shooting out of your blood vessels, and you explode vessels, and you can die if you go too fast. Yeah. Depending on how deep you dive. All right, so we're actually going to solve this equation now. So it wants to know, what is the max depth the diver can go without decompression stops on the way back up.
What are the numbers?
And the equation, T of D equals 1700 divided by D minus 33. Okay? And in the problem, we're told again, T of D stands for the dive time in minutes, and D stands for the depth of water in feet. And we're told that they want to go on a 45-minute dive. So this equation becomes this. 45 equals 1700 divided by D minus 33. And the question is, how do we solve a problem like this? Any ideas?
Multiply.
Get the D out, okay, but how do we do that? Somebody said it. Cross multiply. So, you have to make these proportions. So how do I make these proportions? I put 45 over 1. Because really, when I have 45 as a whole number, what is that as a fraction? 45 divided by 1, right? Then I can cross multiply. So if I cross multiply, I get 45 times d minus 33 equals 1700 times 1. So literally, you cross multiply. Hopefully you've done that before with proportions, things like that. What do I have to do on the left side of my equation there?
45D minus.
Multiply it in. So distributive property, right? So I get 45D minus 45 times 33, 1485 equals 1700.
So D is in.
And now I gotta solve for,
Add 1485 to 1700.
yep, I gotta solve for D, my depth. 45D equals 3185. How'd I get that? I added 1485 to both sides. Again, why am I adding? Because it's negative, right? And I need to make positive.
Yeah, then you
Now I divide by 45. And I get that my depth is 70.78 feet. So what's that saying? The diver can go down 70 feet without having to stop at some point for compression, decompression.
That's
Where
the
did you get
answer.
that number from?
It was given in the problem.
Oh, I don't know. So I wasn't sure. Just pulled those out of there. 1700.
All right. Any questions on how we solve that rational equation?
I just got really confused.
All right. Second example, this one's a little bit more complicated. A plus a squared minus 5 over a squared minus 1 equals a squared plus a plus 2 over a plus 1. So, we look at a problem like this. There's a lot of a's. What is a over as a denominator, really? 1. So to solve this, we would have to have a common denominator for all three. Okay? But we have to remember, what does a squared minus 1, what is that really? It's a binomial, right? So this is really a minus 1 times a plus 1. So we're really not that far away from having a common denominator for all three. But again, do I want to have a denominator if I'm trying to solve for a? I want to just be able to solve for the numerator. I don't want to worry about the denominator. So what we have to look for is what's called the LCD, which is least common denominator of all three. We're going to look for the LCD, which is least common denominator. And then what we're going to do is we're going to multiply the whole equation, both left side and right side, by that least common denominator. So then what that allows us to do is get rid of the denominator altogether. So that way all I have to do is work with the numerator and solve that for a. Just like what we did in the last problem, we got rid of the denominator by cross multiplying and solve for d. We're doing the same thing, but now we're solving for a. So this one has no denominator. This one's a minus 1 times a plus 1. And this one's just a plus 1. So if I want a denominator for all three, It's just going to be this one. So what I'm going to do is multiply all three.
Why is that one?
Why?
Yeah.
So, okay, so if I look, this one has no denominator. So it doesn't really matter. It comes down to these two. So you look and see, okay, well, how can I make it so all three are the same? This is a minus 1, a plus 1. This one is just a plus 1. So the easiest way for me to get all three denominators to be the same is just multiply this by a minus 1 on the bottom to get a squared minus 1. And then this one's just 1, so I would have to multiply by a squared minus 1.
Oh, I see.
So that would give me the same denominator in all three.
Oh, okay.
But again, I'm trying to cancel that denominator in all of them. So what you do is you find the least common denominator, which again is a squared minus 1, and I'm going to multiply the numerator in all three by that. So that way I can cancel and not have denominators anywhere, because that's the whole goal here. So the first one is that. The second one, well, it's already a squared plus or minus 1. So I'm going to multiply the top by a squared minus 1. And then that's all over a squared minus 1. And then the third one, same thing, a squared minus 1, a squared plus a plus 2 over a plus 1. So far, pretty straightforward. So this is over 1. So now I want to try and cancel my denominators. That's the whole goal here, is to cancel my denominators. So if I look at my first one, a denominator of 1, do I really need to cancel anything there? If it's just 1 on the bottom? No, that one's fine. Okay? If I look at the second one, a squared minus 1 on top, a squared minus 1 on the bottom. They're multiplied by each other, so what can I do to those? Cancel them out. That's gone, that's gone. I see a lot of you frantically writing, so I'm going to slow down a second. Everybody okay with where I'm at so far?
75%.
What can I cancel here? A plus 1, right? Because really, a squared minus 1 is a minus 1, a plus 1. So I can cancel that and that.
Wait.
Huh?
Wouldn't it only just be that?
So what?
Page.
Wouldn't it just be a minus 1 then?
Yes, that's all that's left. There, yep.
So it'd be a minus 1.
1 times a squared plus a plus 2. So if I rewrite what I have left, I have a squared minus 1 times a plus a squared minus 5 plus a minus 1 times a squared plus a plus 2. And now that's not plus. What am I
It's
doing?
equal.
That's equals.
How does the a squared minus 1 cancel out a squared plus 1?
Wait, why is it equal? The rest was all plus.
Where?
Oh,
On the right
screwed
side.
up earlier.
The a plus 1 is canceled. So a squared minus 1, I rewrote it as a minus 1, a plus 1, because that's what it is by binomial
Is that
form.
negative a?
It's just a. It's just a line.
Oh, okay.
So I rewrote this as a minus 1, a plus 1. And then the a plus 1 on top and the a plus 1 on the bottom canceled. And the a minus 1 is still there. Does that help or no, Jim?
Yeah.
Okay. So I've officially gotten rid of my denominator in all three. Everybody good there?
Yes.
Okay. So now I got to simplify. A squared times a is a cubed minus a if I distribute that through. Plus a squared minus 5 equals. Now I got a complex FOIL on the right side. So if you remember, how do I do a 2 by 3?
Take everything times everything.
Everything times everything. So a times a squared, a cubed. A times a squared. 2 times a, 2a. That negative 1 times everything. Negative a squared, negative a -2.
Wow. Then combine.
So you have to multiply
Cancel
the
out
A
the
times
A's.
everything.
Cancel
and
out the
one
A
times
squares.
everything.
Right? Cancel
Yep.
out the A squares.
Now, we're going to look and see left and right side if there's anything I can cancel before I start moving stuff around.
You can cancel.
Positive A squared, negative A squared. That goes away. 2A minus A. So I've got the right side, A cubed not equals. A cubed plus 2A minus A is just A, minus 2 on the right side. The left side, I've got A cubed plus A squared minus A minus 5.
Wait.
Hold on.
Oh, I did.
Wouldn't it just be A?
Yeah.
On the right side.
No, on the other side.
Can you
Because you have
subtract
negative
A, so you
A.
can just have A.
Can't you just?
You just have
You
A.
Oh, you just
A
rearranged.
I just
cubed
rearranged.
plus-
I didn't do anything.
That's
All I did was
Subtract
rearrange.
the A squared minus the
They don't have the same power. So
They don't have the same power, so I can't combine.
A. I suppose.
Now, I got to move everything to the left side now. So if I minus A cubed, those go away. Those cancel on both sides. So I've got A squared. I minus A. Negative A minus A becomes negative 2A.
Did you add?
Wouldn't that just
Can we
cancel?
turn into a plus?
No, because that becomes plus negative. And then plus 2.
So negative A plus A equals 0.
How would it turn into?
That is equal to 0. So we just have to solve for A.
All right.
You lost, man.
So all I did here was move everything to the left side. This was a positive A cubed. So I subtract that from both sides. This one and that one cancel. There is no A squared term, so that just comes down.
Oh, okay.
This was a positive A, so I subtracted it from both sides. So that's gone. Negative A plus negative A is negative 2A, because there's 2 negative A's. And then I added 2, because this was a negative 2 to cancel that. Negative 5 plus 2 is negative 3.
Well, I suppose.
So now
Answer?
we have it down to a quadratic.
Oh, that's not the answer.
So I just either do quadratic formula or complete the square or factor.
The quadratic.
So this actually factors by AC. So it's negative 3.
-3 times 1,
Negative 3 times 1.
which is A.
So I got A squared minus 3A.
And could you just skip the middle steps?
You could. Plus A minus 3 equals 0. Split down the middle. A times A minus 3. And this side, it's just 1 because there's nothing to pull out. Put them together. A plus 1. A minus 3. So what's A equal? Negative 1 and positive 3.
It's just a lot of A's.
So the biggest thing you have to do is find a factor that works for all 3. Once you get that and cancel it out, then it's just a lot of multiply and rearrange. It's base algebra after that. Get rid of the denominators first. I know that's a lot of steps to find an answer. There's a lot of A's there, but if you keep track of everything and follow it step by step, you should be fine. But the big thing here is if you lose an A or don't keep track of where you're at, you're going to get lost pretty quick. So you have to maintain and keep steps as you go.
That was rough.
Okay.
Why did you turn on such a big problem?
All right. Any questions on what we did there? All right. All right. Now we're going to look at how we can use that same concept similar to what we just did in what we refer to as partial fractions. Partial fractions. So we want to figure out, how can I break down an equation into two separate fractions, an A and a B? So,
Hey, don't take this the wrong way, but is there any way you could like slow down or like pause for a little bit longer when you're done writing?
Yeah.
Okay, great.
all right. Decompose 8y plus 7 into over y squared plus y minus 2 into partial fractions. Into partial fractions.
8y over y.
Y squared plus y minus 2. Okay. So to do this, it's a couple step process. So step 1, we have to factor the denominator. Okay? Step 2. Step 2 is to write factors as A over your first factor, factor 1, plus B over your second factor, factor 2. Whatever you get from part 1. What are you looking for, Chase?
4.
Not in there, behind my desk. Chase, behind my desk.
Yeah, I know.
Oh, okay. Step 3. You're going to multiply by that denominator. Okay. Step 4. Solve for A by eliminating B. Then solve for B by eliminating A. And the last step is write as partial fraction.
That's a lot of steps, Kyle.
Okay, so it's a 6-step process.
There is no one step process that we can do.
No. Alright. So, what is my denominator first up?
Y squared plus Y minus 2.
Okay? So step one is to factor that. So we set that equal to 0. And we're gonna do AC method. So if I do AC, A times C, what do I get?
2.
-2. Give me two numbers that multiply to -2 and add to +1.
2 and 1.
2 and -1.
You know what?
So I'm gonna get y squared plus 2y minus y minus 2 equals 0. Or again, you could skip that middle step if you want and go straight to the factors. So factor out of y plus 2. Factor out of -1, y plus 2. Outsides go together, y minus 1. Insides the same, y plus 2. And there's my two factors, right there. Y minus 1 and y plus 2. So that's step one. Write it as factors. Or get it two factors. Okay?
You don't want it solved like y.
Nope, I don't. You don't want to solve it. That's all the farther you want. I don't want to solve that all the way out. So now, what I do, so that's step one. Step two, 8y plus 7 over y squared plus y plus 2 equals a over y minus 1 plus.
Mr. Kyle, in the top you have it y squared plus 1 minus 2, and then down there you have plus 2.
Where?
At the top you have it in black as minus 2, and at the bottom
Oh,
it's plus
you're
2.
right. That should be minus 2. Thank you. Alright. So that's step two. Write it up as factors. A over one factor, B over the other. Okay? And again, the goal here is to solve for A and B. It's the whole goal of this process. And A and B are just going to be numbers. Simple numbers. So, we've done step one in blue. We did step two here in red. Step three, multiply the whole equation by the denominator. So, if I do that, y squared plus y minus 2 times 8y plus 7 over y squared plus y minus 2. Y squared plus y minus 2 times a over y minus 1 plus y squared plus y minus 2 times b over y plus 2. So all I did was multiply everything by the denominator. That's all I did. Now I got to try and cancel the denominators in every case and see what I have left. So left side, what happens when I cancel or when I multiply by y squared plus y over 2? Yeah, that's gone, that's gone. Okay? What happens here with a? What's going to be left on top with a? What is this factor to? What did we just say it factors to? This is really y minus 1 times y plus 2. So what's going to cancel? Y minus 1. So if somebody said the opposite factor is what's going to be left. And that's true every single time. And then same thing here. What's going to be left? Just, so you got y minus 1 times y plus 2. Now the y plus 2's cancel. So what's left? Just the y minus 1. So that's gone. That's gone. So if I write out what I have left, I have 8y plus 7 equals y plus 2 times a plus y minus 1 times b. So I got rid of my denominators altogether.
How? How'd you take out those numbers by subtracting by 1? There's still a 2 and stuff. What do you mean? On the.
All right, hold up here.
I'm actually
So,
doing it, I just saw it.
Writing this as, don't let the mass amount of stuff written here confuse you. Y squared plus y minus 2 is really just y minus 1 times y plus 2. So I multiply by both factors. I look, what factor is left on the bottom? Y minus 1. So that factor is going to cancel off of top and bottom. So all that's left is the y plus 2. And then you do the exact opposite here. So if it's helpful, write it in factored form every time. That's usually what I do. Once I show it to you once, I'm just going to write it in factored form because we just did it right here. That's the whole point of factoring it, is so when I go to multiply by the LCD, it makes it easier to simplify. Okay, so we are through step 3. Step 4, solve for A by eliminating B. So now I look and see, okay, what is my constant out front of B? Y minus 1. Yeah.
Just gonna write the equation twice. 1 equals.
Yep, we're just going to solve it twice. Yep. So what do I need to put in for Y to get rid of B? So if I look, Y minus 1. How do I get rid of B? I need to make the number out front of it 0. So what do I put in for Y to make this a 0? 1. So I plugged 1 in for Y everywhere I see it. 8 times 1 plus 7 equals 1 plus 2A plus 0B, which that's going to cancel, which is what I want. 8 times 1 is 8 plus 7 is 15. 1 plus 2 is 3A.
Wait.
Oh, so it's 5. Half the A equals 5.
Oh, I see what you did. Never mind.
So A equals 5. So that was step 4. Solve for A by eliminating B. You need to make B 0. So you just eliminate B.
So then you just make.
Now I need to do the same thing. So I put negative 2 in. So 8 times negative 2 plus 7. It's 0A plus negative 2 minus 1B. 8 times negative 2 is negative 16 plus 7 is negative 9. 0A goes away. Negative 2 minus 1 is negative 3B. Divide by negative 3. B equals 3. Negative divided by negative is positive. So now, my answer, 8y plus 7 over y squared plus y minus 2 is equal to A, 5 over y minus 1 plus B, 3 over y plus 2. That's your answer.
What the?
Find A, find B.
So you're just saying it's equal to that.
Yep.
You need to write the left side or no?
You don't really need to write the left side, no. Yes, him.
So what if you just stopped with like A equals 5 and B equals 3? Would that be enough or no?
No, gotta write it as partial.
You only need to write the right side though.
You only need to write the right side.
That was
Rough. Alright, so we will do another one of those tomorrow and keep working in this lesson.